Hello viewers, welcome back in a brand new video in GIS and AHP Solution YouTube channel. Hope you are doing very great. Today's tutorial is very important for you. I had received many requests to make a video on flood susceptibility mapping. So finally I'm going to explain and show you how you can perform flood susceptibility mapping using ArcGIS and AHP Multicriteria Analysis of flood causative factor. So here you go. First, we need to select flood factors or variables. For this tutorial, I have selected total 10 parameters like topographic wetness index, elevation, slope, land use and land cover, drainage density, precipitation, NDVI, distance from active channel and distance from road, soil type were measured and evaluated for identifying flood causative factors. We know a higher precipitation rate considerably increases the probability of floods. High river network density in our region implies accelerated surface runoff and increases the possibility of flooding. Flood intensity and frequency are very high around drainage basin area, particularly closer to rivers. High values of topographic wetness index correspond to areas favoring water accumulation and high runoff. And also in land use and land cover change dynamics parameters affect hydrological processes components such as infiltration, surface runoff, evaporation and evapotranspiration. In order to combine the dataset, they must be in a common scale. We have to reclassify all the thematic maps and need to be organized on to 5 scale for each factor. For weight calculation of all factors, I will use ASP techniques, multi-criteria analysis using this ASP Excel sheet. You will just need to your expert opinions to rank the factors and put the factors in this Excel sheet, and it will calculate automatically and give you the weight. I have shared the download link of this ASP Excel sheet in the description section of this video. You can download easily. I did not show here most of the thematic map preparation as I have already uploaded all the thematic map preparation process in other videos in this channel. Just go to my channel and click in videos. And here in search box, just write slope and you will find the slope preparation map, how you can prepare a slope map. And if you want to get how to prepare precipitation or LULC or elevation, just search here like rainfall. You will get the rainfall map preparation video from here. You will find everything about thematic map preparation from here, LULC, NDVI, everything. LULC, and you will get several land use land cover map preparation technique in ArcGIS, in NV, supervised unsupervised classification technique for land use land cover map preparation. Also you will get NDVI preparation. I have given the link in the description section of every thematic map preparation process that has been used in this video. Distance from river, distance from road, drainage density, every thematic map you will get from my channel. That's why I did not show you in this specific video. In this video I have shown several variables preparation like distance from road, river, slope, and others also. You will also get this thematic map from here. I did not upload topographic wetness index map yet in my channel. So first I will show you how to prepare topographic wetness index map. So topographic index map, it is also called compound topographic index. It is used to quantify topographic control on hydrological processes. And here step for topographic wetness index. First we need DEM. So go to ArcMap. Here is our study area of interest, and here is our DEM data, DEM raster. So first we will perform fill DEM. Fill DEM. For doing that, go to Arc toolbox and then spatial analyzed tools and then hydrology and then fill. Double click on here and then add DEM as input surface raster, and then environments processing extent, add it will be as per area of interest, then okay. Fill has been completed. Now flow direction. Now I will show you how to perform flow direction. Click on flow direction. Input surface raster will be fill DEM, then click OK. Here is flow direction. So flow direction has completed, and now flow accumulation. Click here, flow accumulation, add flow direction in input flow direction raster, then output accumulation raster. I'm going to rename it flow accumulation, and then click OK. Flow accumulation also has been done. And now slope in degree, slope map. For doing that, go to surface and here click on slope, and input raster will be fill DEM as input raster, and output raster, and then output measurement will be degree, then click OK. Our slope map has also done. And radius of slope. To do that, go to map algebra and then raster calculator. We have to add slope in degree, then this value, and here add slope, and I'm going to rename it as radian of slope. It has done radians of slope, and now tan slope. So you have to perform this tan slope. For doing that, go to again raster calculator and then condition radian slope, then greater than 0, then tan, then radian slope, and here put the value 0.001. Output raster, you can save output raster in a folder where you want to save, and I'm going to rename it as tan slope and click OK. So tan slope has been done, and then flow accumulation scaled. Again go to raster calculator, first bracket, and then flow accumulation plus 1, first bracket close, into, go to flow accumulation, then copy the cell size and paste here. Cell size. Output raster, I'm going to rename the output raster as upslope, then save, then OK. Upslope has been done, flow accumulation is scaled, and then finally topographic wetness index. So for doing that, you have to perform this equation. Go to raster calculator, then ln upslope slash divided by tan slope, output raster, save output raster. I'm going to name as TWI, topographic wetness index, and then click OK. So our topographic wetness index has been done. Now you can classify it. Go to properties and then symbology, classified. You can change the color. You can change the color according to your preference. Now I don't need this data, flow direction, flow accumulation, upslope, so I'm deleting this raster. So our topographic wetness index has done. So we have got all the thematic maps here. Now we can see here topographic index, then class, and according to class value, I have arranged here susceptibility class ranges and ratings. I will describe one by one. In order to combine the dataset, they must be in a common scale. We have to reclassify all the thematic maps and need to be organized 1 to 5 scale for each factor. classify, input raster, add topographic wetness index, and then old value and new value. So topographic index, the lower value means very low probability for flat, very low to very high. So it will be 1 2 3 4 5. And then output raster, I'm going to rename it topographic wetness index and reclassify RC, then click save. Environments, processing extent will be the area of interest. Raster analysis, it will be mask data also will be area of interest, then click OK. So topographic wetness index data has been reclassified 1 to 5. You can change the color. Then elevation, again reclassify, click here reclassify, and add elevation as input raster, and then old value and new value. So for elevation, lower value means very high probability for flat. I mean lower value to higher value, that means very high to very low flat probability. So 5 4 3 2 1 it will be the class range. So it will be 5 4 3 2 1 reversed new value. 5 4 3 2 1 very low value means for elevation is higher flat susceptibility. Then output raster, save output raster. I'm going to give it a name, elevation reclassified RC, then save and then click OK. Elevation raster has been reclassified, and then slope, and again reclassify, input raster slope, and then the new value will be for slope lower value to higher value means very high to very low flat probability. So it will be 5 4 3 2 1. Lower slope means very high flat probability. It will reverse 5 4 3 2 1. Save the output raster, slope RC reclassified. So slope has been done, reclassified, and then precipitation reclassify again. Input raster will be precipitation, and then for value, new value. So for precipitation, so lower precipitation means very low flat probability. So lower to higher precipitation means very low to very high probability for flat risk. So it will be okay, 1 2 3 4 5, low to high, and then rename the reclassified raster for precipitation RC, then save, and then here's a problem, output raster, the length of the grid been maybe it is too long, the name. So I'm going to decrease this, and then I think it will be okay. Yeah, okay, then okay. So precipitation reclassification has done, and then land use and land cover map LULC, again reclassify, then add LULC as input raster, and for value and new values, Water body is higher probability for flood. Water body, yeah, very high probability for flood, so it will be 5. So 1, it will be 5. Then 2, barren land. Barren land will be low, comparatively low for flood risk. Comparatively low in terms of this classification. Then vegetation will be very low, so it will be 1. And then for agricultural land, it will be high, so the rank will be 4. It is already 4. Then 5, settlement is moderate for flood risk. Here 5, it will be 3. Then output raster, save output raster, LULC RC, then save and then OK. LULC has been reclassified, and then NDVI, normalized difference vegetation index. So add NDVI as input raster and then new values. So for NDVI, lower NDVI to higher NDVI means very high to very low flood probability. So it will be 5 to 1, the reverse new value 5, 4, 3, 2, 1. And then output raster, rename NDVI, reclassified, then save. Okay, so our NDVI has been reclassified. And then distance from river, reclassify, input raster, distance from river, and then value for distance from river, very low to very high distance, it will be very high to very low probability. I mean, closer river distance means high probability for flood. Then okay, so distance from river reclassification has done, and then distance from road, again reclassify. And then for distance from road, lower value to higher value, I mean lower distance to higher distance, very high to very low. So 5, 4, 3, 2, 1, it will be reversed. 5, 4, 3, 2, 1. Then output raster, save output raster and rename. Save and then okay. So distance from road has been done. Then drainage density, again reclassification, input raster as drainage density, then value for drainage density. Lower drainage density means very low flood probability, higher drainage density mean high flood probability. Then rename drainage density, then reclassification, RC, save. Maybe the name is too long. Now I think it will be okay. Yes, then okay. So drainage density classification has done. So our all thematic map reclassification has done in a scale 1 to 5. Now I will show you how to calculate thematic map weight using AHP Excel sheet for GIS input. So here is our AHP Excel sheet. Here you can write of your study title in objectives section, and here in the flat criteria write the wall criteria here. I mean all the factor, elevation, slope, LLC, and all the factors you have to write here. And then here you can see the criteria I have written here. And then this criteria box, you can see here criteria A and B. I mean more important, what is important, A or B. And then a scale 1 to 9 scale, 1 equal importance, 3, 5, 7, 9 the category of a scale. And here you can see what is important, A or B. I mean TWI important or elevation. I think TWI importance then elevation, and it is scale 1, I mean equal importance, then TWI or slope. Of course TWI and slope, it is equal importance, then precipitation or TWI A, and both are equal importance, then TWI or LULC, it will be A, and then TWI is important, then LULC, so the scale will be 3. And TWI and NDVI, of course TWI is more important than NDVI, so it will be A, and in a scale it will be 5. And TWI or and it will automatically calculate the weight here. Distance from river or topographic wetness index, of course topographic wetness index, and it will be 1, I mean equal important. And distance from road or TWI, and importance, I mean in a scale, it will be 5 or 3 or 2. You can it will be based on your expert opinion, the criteria. And similarly you have to compare this criteria to criteria, elevation or slope, elevation or precipitation, elevation between elevation, LULC, elevation NDVI, and put the scale value and importance. Like slope or distance from river, distance from river is more important than slope, that's why I write here B. And here LULC or distance from river, distance from river is more important than LULC, that's why A, and it is important in 3 scale. Similarly you have to write all the criteria here. And for consistency ratio, you have to consistency ratio is less than 0.05 for 3 into 3 matrix, and 0.09 for 4 into 4 matrix, and zero point 0.1 for large matrix. And if it matches, then the pairwise comparison matrix is said to be consistent, and it will be automatically calculated in the ASP Excel sheet using this formula. You can see our consistency ratio is 5%, I mean 0.005, and the weight is automatically calculated here. Finally you can see here weights for all factors, and here matrix, and also normalized principal eigenfactor. You can use these metrics in your study report. So now I will write here the weight. For TWI it will be 14, 12 for slope, it will 10, and the sum of factor it weight it will be 100. Now in ArcGIS I will put all the factors and weight using overlay weighted technique. So for that, go to overlay and then weighted overlay and add all reclassified factors. Drainage density, then OK. Similarly, add all the factors here. Drainage density, scale value, add all the factors. Distance from road, distance from river, NDVI, LVLC, add all factors one by one. Precipitation, slope, elevation, TWI, topographic wetness index. After adding all the factors, you have to write the weight, I mean influence here. Here for drainage density, the influence is 15. I mean weight is 15. Then distance from road, it is 6. Similarly, you have to write here all the weights. And sum of influence it will be 100, and evaluation scale it will be 1 to 5 scale. And now you have to rearrange the scale value 1 to 5. And then output raster, I'm going to rename it as flood risk. Then click save. Maybe between space, so we have to reduce the between space. So our flood susceptibility map has been done. You can see here high risk, moderate, low, very low risk. I hope you enjoyed this video a lot, and it will be helpful for you to get an idea and a way to prepare flood susceptibility map. I have given all the necessary links including ASP Excel sheet for your further practice. Hope you will able to perform flood risk map without having any problem. If you face any issues while practicing, or if you have any questions, just write me in the comments section or our Facebook group. We will cooperate you. Anyway, if you find this channel helpful, please don't forget to subscribe and share with your fellows, and who already subscribed, thank you so much. See you in the next video. Stay safe and healthy.